All right, let's go over this quiz on interpreting linear models. Try to kind of explain some things to you, and hopefully it makes a little bit more sense. So Jordan works for the Geek Squad at Best Buy. Each week he receives computers that need to be repaired. The number of computers he has left to fix, so this is important, left to fix at the end of each day can be estimated with an equation. C equals 58 minus 9D. And C is the number of computers left. So that number of computers left, that word's important. It's not the number that they've completed, it's the number left. So number of computers left. And then D is the number of days that she has worked. So D represents days. And remember, a lot of times when I do problems like these, I like to make a small table just so I can get a feel of what's going on. I can see the y-intercept, I can figure out the slope. So the ultimate question here says, what is the meaning of the value 58? What does the 58 mean in this question? Well, let me kind of go through the table part first. So if I'm going to start making a table, and at 0 days, if I plug 0 into here, basically I'm going to write the equation, and I'm going to say 58 take away 9 times 0. Well, that's 58. So how I interpret this is, on the very day 0, I haven't even started yet, C means I have 58 computers left. All right? So on day 0, there's 58 computers left. When I put 1 day in there, I would do 58 minus 9 times 1, which is going to give me 49 computers left. If I plug a 2 in there and I keep going, I'm going to subtract 9 more, and there's going to be 40 left. Now you can kind of see that in the equation. Because this number is not connected to a variable, it's the y-intercept, or it is the initial or the starting amount. So we're starting with 58 computers left. And then our slope, or our rate of change, is right here. We're decreasing because it's negative. We're decreasing by 9. And you can see that in the chart over there. We're dropping by 9 computers every single day. So the 58 represents, that's what we start each week with. So the correct answer here was B. It may not have been B on everybody's test, but the correct answer was that Jordan starts each week with 58 computers. All right, next question. Moving on down. Number 2, still the same thing about Jordan at the Geek Squad, so we can kind of use everything that I just mentioned. So this one might go a little bit quicker. And I have our table. And since we've already kind of did this, the number 9 represented the problem. That's how many computers that can be repaired each day. All right. So it looks like 9 computers can be repaired in a day. Because when we had that little chart here, and I have the D and I have the C, you know, we're at 0, 58. Well, then at 1 day we were down to 49. At 2 days we were down to 40. So the 9 represents how many computers are being repaired. All right. Next one. The speed of sound wave in air depends on the air temperature. And the formula A equals 1052 plus 1.08 T can model the relationship between speed and temperature. So A is our speed, T is our temperature. So since this is increasing, it looks like every time the temperature goes up by 1, our speed actually increases by 1.08 feet per second. But the final question says, at which of the following temperatures will the speed of sound be closest to 1107? So when's it going to reach 1107? Well, there's a few options. Option A is, we want the speed to be 1107. if you're good at solving algebra, which this equation isn't too bad, it's pretty much just 2 steps. If you're good at solving algebra, I would say just solve for t. All right? So let's just solve this thing for t. Now, if you are not very good at algebra, but you still want a shot at getting the question right, second method would be to plug in the answers. Now that may take longer, it may take shorter, depending on which answer you start with. But for instance, if you try 49, if I do 1052 plus 1.08 times, and let's say I try 49, you're not going to get 1107. All right, you're going to get a different answer, so you'll know that that one's not right. I'm going to actually solving it. I'm going to do the problem just by solving. So my first move is I'm going to subtract the 1052 from both sides. And that isolated my variable term. I got the t term all by itself. That's going to be, 48 plus 7, 55. And then I'm going to divide by both sides by that coefficient, 1.08. And I pop that into my calculator. Let me reach over and grab my calculator. 55 divided by 1.08. Boom. I'm getting about 50.92, which the answer that looks closest there would be 51 degrees. Question number 4. The equation above gives the amount C in dollars that a plumber charges for a job that takes 8 hours. So this equation is a cost equation. The slope is 80 because it's in front of our variable. The 110 is our y-intercept because it's by itself. So C is money. H represents the hours. So if I kind of just think about this little table here, you don't always have to make a table, but I like to just do it, especially when I'm first learning how to do this stuff. If I plug 0 in for H, and I do 80 times 0, well, that's 0. So how I interpret this is this line basically means that the plumber charges $110 just to show up. Like 0 hours work, they're charging you $110. Now, if they put in 1 hour's worth of work, now I have to go to the equation and put in a 1 for H, and then add the 110 for showing up, and you get 190. And every hour thereafter, we're just going to keep adding $80 to it. So the meter's running. Plumber's making money. And so on and so forth. All right, maybe I'll even go a little bit further just to show what a really good day looks like for this plumber. So another 80. Hopefully I'm doing that math right in my head, but that looks like what's going on. So, what do they want to know? Mr. Kraft and Mr. Davis each hired a plumber. So I think I better go over here and I better write Kraft and I'm going to write Davis. They both hired the plumber. The plumber worked 3 hours longer for Davis than he did with Kraft. So let's just play a little what if here. Let's say that Kraft hired the plumber for 2 hours. I just picked that number on my own. It said the plumber worked 3 more than Davis. Or 3 more on Davis's job. So that would be 2 hours for Davis. How much more, so that's a subtraction problem, how much more did Davis get charged than Kraft? We'll kind of look at my chart here. Davis got charged $510. Kraft at 2 hours got charged $270. So if I want to know how much more, I subtract those two. 510 minus 270. And it looks like it's going to be 100, actually, check that, $240 would be how much more. So the correct answer is right there, 240. Now, I probably should have, if this would have been a better written test, the SAT would have probably put both of these numbers as answer choices and tried to get some of you guys to shut down early and pick one of those. So just kind of be careful on that. I should have made that a little bit tougher. Question 5. The graph below shows the percentage of the battery's capacity that it is charged as a function of time. The situation can be modeled by an equation, C equals 2t plus 40, where C is the capacity, the percentage, and T represents how many minutes. So kind of looking at my chart here, and I'm going to have to shrink this problem down just a little bit because it's awful big. That way we can see all of our choices and all that good stuff. So hopefully that'll be enough to see there. So again, how you kind of interpret the chart is, this is the percent. This is the percent that the battery charges. And down here is how long it takes in time. So for instance, it looks like right now, right here, it's at 40% capacity to begin with. And then if I kind of move over and I go up to, it looks like at 5 minutes. So it looks like in 5 minutes, it's now up to 50% charged. And eventually, all the way over here, we're at full charge, 100%, and it took a half hour. So it took a half hour to go from 40% to 100%. So which of the following statements is true based on the information given above? And then we also had our equation, which I kind of lost, 2t plus 40. So let's go back and put that in here. So the charge is 2t plus 40. So we always could do a little chart if we wanted to. Remember, this is the percentage, and these are the minutes. And I could say, well, it's 0 minutes. We're at a charge of 40. If I put 1 minute in there, so if I go 2 times 1 plus 40, that would be 42. And now I can kind of see the pattern, which I already kind of knew the pattern. I saw the slope, and I know that's the rate of change, so I know that's what this C value is going up by. It's going up by 2. So if I wanted to, I could kind of keep running this table. And you'll notice that the chart should match over here, although we don't really have 1s and 2s and 3s. They kind of just jump to like 2.5 minutes right here in the middle. But all those numbers would be on the chart. And then when you get to 5, you have 2 times 5 plus 40 would be 50. And that corresponds to this dot right here. So one of these is true. The battery begins charging when it's at 2%. No, I don't see anything down here around 2%. So you're out. B, it takes 2 minutes to go up by 1%. So 2 minutes to go up by 1%. Well, when I look at my table over here, in 2 minutes, it actually didn't go up by 1%. In 2 minutes, it went up by 4%. So that's wrong. Part C, the battery capacity increases 2% for each minute. I think that one is going to be a right answer. Let me just kind of go up a little bit. And I think that one's going to be good because every minute, when I go over here to my chart, every minute it goes up by 2%. So I like the answer C. Next question, number 6. Anju wants to make t-shirts to sell at a craft show. T-shirt company charges a one-time screen print fee. So remember, this is your y-intercept, which is the number that does not include a variable. So we're looking right here to make the design for the shirts. So what does the 45 represent in the situation? Well, whenever you're a y-intercept, you're going to represent either the initial fee or a one-time fee. So right now I'm pretty sure that the correct answer is going to be B, the screen print. But let's just kind of double check it really quick. And I think this will help answer number 7 as well. So if I have my total price there, plus I have the number of shirts, and we kind of pick 0 because N was shirts. If I pick 0 for shirts, and I'd use $6.95 times 0 plus 45, Well, that's just going to come out to be 45. So basically what that meant was when I make 0 shirts, it's still going to cost me $45 because I got to pay for the screen fee. But then when I do 1 shirt, first time I make my very first shirt, it's going to be $6.95 times that 1 plus the fee. So now it's going to bump up to $51.95. So you can kind of see how the equation is built here. This 45 is for the screen print, and the $6.95 is tied into how many shirts there are. So this is the price, if I could spell it right, this is the price of each shirt. So for this problem, 45 does represent the screen print. If we go to the next problem, it's going to ask about the $6.95, and since we just answered that in the last question, the $6.95 represents the price of each shirt, which unfortunately I screwed up and I had 2 answers that were the same. So either one of these would be the correct answer, the price of each shirt. All right, moving right along, number 8. We have an equation about the number of years. Talks about height of a species of pine tree. So let's kind of figure out our height is y. So in our equation, we have y equals 24 plus 3.4x, and the y represents the height of the tree, and the number of years x after it was planted. So this is the years after it was put in the ground. Excuse me. So then we can make a little table if we wanted to. And again, I always want to understand before I even start the question, this is the y-intercept. There's no variable there. So that is my starting amount. That's my initial amount. Meaning that if I put 0 in for x, if I plug a 0 right here, and I do 24 plus 3.4 times 0, that means that this tree is 24 inches tall at 0 years, basically at birth when I stick it in the ground. Then if I go 1 year later, I do the 24 plus, I do the 3.4 times 1, which is going to give me 27.4. So I can kind of see what's going on here. It says when the equation is graphed, what is the y-intercept? Well, again, the y-intercept is simply that number over there. And if I think about it on a graph, if I have years and I have inches, 0 years should be at 24 inches. And that is going to be the y-intercept. So it is A, the height of the tree when it was planted, when it begins. All right, moving right along. Number 9. Have an equation, 140x plus y equals 2,000. Let's just pop that in here. 140 times x plus y equals 2,000. Notice right now, it is not in slope-intercept form. It's in standard form because x and y are on the same side. You could very quickly, if you wanted to, if you subtracted 140x from both sides, you could rewrite it like this. And now it looks a little bit more normal. But either way, it should be fine. But now you can kind of see what the y-intercept or the starting point is. Now you can see the rate of change, which is negative 140. So this equation is actually dropping. It says Costco is running a promotions, giving away free samples. The equation above can be used to model the number of free cookies that remain. This is where people made their mistake. Y is cookies that remain, all right? And X is the days after the promotion started. So when I make my little table here, and I make my X, and I make my Y, X was days, and Y is the cookies that are left or that remain. So it wants to know, what does this solution mean? Well, if I put that solution on the chart, how I read that is, after 12 days of promotion, there are 320 cookies left. So when I do that one, the correct answer is going to be C. I know a lot of you picked B. 12 days, there's 320 cookies given away. This word right here is kind of what tripped you up and is what made B a really good looking wrong answer. All right. Keep on going here. We're looking at number 10. And this one is kind of a big picture, so I'm going to have to try to shrink it down. So let's just go down here and see if we can kind of minimize the scale a little bit. You guys have it in front of you, so it shouldn't be too big a deal. If you can't see it perfectly on the screen, come on, man. Shrink, shrink. All right, here we go. So let's see what we got here. Cost of a boat, renting H hours. So we have time on the bottom. We have money on the side. And the question says, what is the cost for each additional hour? Well, if I look at the chart, if I make a little table, time, and then I do my cost, my dollars, well, at 0 hours, it's $5. Must just be $5 just for the boat rental. Then at 1 hour, it's $8. At 2 hours, it's $11. So I can see right now, for every hour I rent the boat, it's a $3 additional price. So the correct answer here is C. All right, moving on down to question 11. This was the question that had 3 parts. It was worth 3 points, 1 for each section. So we have a savings account, and the equation flows A equals 20W plus 25. It says A is the dollars, and W is the weeks. So, just looking at the equation, my y-intercept is the number all by itself with no letter. So I know right here is my y-intercept, okay, which should represent my starting amount, and it is. What was the initial deposit? The initial deposit was $25. Okay, and how much do they add each week? Well, that's how much it's changing. That's the rate of change, which is actually going to be the slope. So the correct answer here is 20. And you could use a table. I always like to set up tables if I'm not quite sure what's going on. And if you plug in 0 for W, you're going to get 20 times the weeks plus 25. So that comes out to be $25. So what that means is at 0 weeks, we had $25 in our account, which is why that answer is what it is. And then how much are we adding a week? Well, when I go to the next week, I'm going to do 20 times 1 plus 25. So it's 45. So I see that we're going up. We're increasing by $20 for every 1 week. Now, the final question says, how much will be in the account after a year? Well, I interpreted the problem because I thought there were 52 weeks in a year. So when you plug in 20 times 52 weeks and then add your initial deposit, I got 1,065. So I put that as the right answer. Well, I kept seeing a lot of people that had some weird answer like 1067 and some change. And I'm like, what in the heck? He's not putting any pennies in the account. How's that happen? Well, a kid explained it to me. He said, I forgot how many weeks were in a year. So I went to Google and typed in weeks in a year. And it actually popped up that if you count leap years and average it, it's like 52.1429 or something. I have no idea. I've never heard of this in my life. But there are a little over 52 weeks in a year. So if you were to plug this number in right there instead of just 52, you do get this. So I did go back in and I changed those questions to correct, even if they're a little goofy. But I guess technically they are right. So I went ahead and gave you that.